So thanks for coming. My name is Pete Yaworski. I am with the application security team at Shopify, but I also do bug bounties on the side. I've been doing that since the end of 2015 or so. So that's on HackerOne as well as Synac. I've written a book, which is self-published right now, Web Hacking 101. It's on LeanPub, but I've got the hard copy of that coming out with no starch, hopefully in Q1 of next year. And also I record pro tips interviews with top hackers on how they approach a target, what they look for, what their advice is for new hackers, and that includes some deep dives with guys at BugCrowd. So what I wanted to go over today was really how hackers are going to first approach your system and then how they're going to attack it. And when I say they're going to attack it, we're going to look at 5 specific attacks that are common, but not so not so common. Ones that I see play out, other hackers miss, but they're not new. They're not new techniques. They're old in some cases, but for whatever reason they've been forgotten. So I've been successful with them. Hopefully they'll help you because the concepts of them are easily changed and applied to different vulnerabilities that are out there. Of course. So, as I mentioned, first we'll talk about Reconnaissance, how an attacker is going to look at your web property, and then we'll look at attacking that functionality. If we have time, we'll also go into some red flags, but I don't know if we'll get there. So when I talk about Reconnaissance, what I really mean is 5 different areas that we're going to take a look at. There's much more, but these are kind of like the basic that most hackers will apply to coming after your system. So the first is subdomain enumeration, kind of what's available out there. Next would be port scanning. So if I enumerate your subdomains, I want to know what services are available on them. Next, if I have this massive laundry list of subdomains, I'm going to want to visually screenshot them so I can just take a quick look and peruse through them. If I have 1,600, 2,000, 3,000 subdomains in some cases, it's impossible to review them all. So visual recon gives me the ability to look at what's available. Next, once I have those properties, I'm going to want to look for sensitive files, directories, what functionality is available on the site but isn't necessarily published that I can find, or what backup files have you left on a site that I can grab and peruse. And lastly, if you've published any secrets, there's plenty of ways that those end up being exposed, and we'll look at some of the methodologies for that. So as I mentioned, subdomain enumeration is really going to be about finding your digital footprint. What subdomains have you made available online that expands your application's footprint? And a good example of why this is pertinent is if you have a random subdomain, but all of your cookies are scoped to the core domain, so .example.com, a crappy XSS on a subdomain is going to be applicable to your main application. So a handy tool here is SubFinder. SubFinder, you just pop in the domain that you're looking for, give it an output, and then have at it. It has a laundry list of sites that it's going to go after as sources to pull information from. And so that'll include like Google, certificate transparency, virus total, Wayback Archive, Yahoo, Baidu, just a whole host of them. And you'll see right at the beginning of the GIF, it lists the sources that it's going to use, and then it just fires off into them. If you actually check the GitHub repo for this tool, it will give you all of the different sources that it uses. Alternatively, at Shopify, and your application might be the same way, we have automatic tooling to deploy subdomains or different applications. And so when we do that, we'll automatically grab SSL cert for that subdomain from Let's Encrypt. So anytime we spin up a new, let's say, microservice, that microservice is going to get its own SSL certificate. What that means for an attacker is if you just monitor our certificate transparency logs, you'll automatically see when we post a new application. And so we recently had a hacker. This report isn't referenced to it because actually we have published it, so I can add it. But we had a hacker who, within 5 minutes of an application going up, realized we didn't have auth on that application, and that application gave the titles of every Zendesk ticket that we had. Zendesk or GitHub security issues that we had. And so within 5 minutes, he had reported it to us. We paid him, and we took it down. This report that I'm referencing there, 150374, hacker used certificate transparency to realize that we had let a subdomain slip So we had windsor.shopify.com. We didn't renew it. We just let it go. So it was pointed to our domain. Nobody owned it. He grabbed it. And now he can serve content from windsor.shopify.com. Alternatively, if you're using a wildcard cert, all is not lost for the hacker. With SubFinder, SubFinder was the predecessor for SubFinder. If you look at SubFinder, you can just throw in the -b flag, and that will brute force. You just have to give it a list of subdomains that you want to brute force. So Jason Haddix from BugCrowd has an awesome list. I think it's 1.3 or 1.6 million of the top popular subdomain names, and you can just brute force and have at it. Other tooling and hackers who specialize in this will just take permutations of what they find you naming your sites like. So you'll see with Shopify, we have a whole bunch of random stuff. They'll just take that and then create the proper permutations based on the patterns that they're seeing you name your applications by, and they'll just brute force. And if you have a wildcard on top of, say, like a corporate domain, like Google does, like star.corp.google.com, just brute force that as well, right? Like you can just go layers and layers deep to find different properties. Some specialize in you having an application up for 30 minutes or an hour just because it's ephemeral, you want to test something. Some hackers are automating this, so it's just constantly banging your site to see what's available and what they can test. And if it's up for 30 minutes or an hour, that's more than enough time to find a SQL injection or anything applicable if it's just a test domain. So once you have this list of subdomains, you're going to want to port scan them. So by port scanning, we're going to see what services are available and online. So there are two tools that are very handy for this. First is a newer player to the game, MassScan. It's a tool that's developed and, according to the documentation, can scan the internet in 6 minutes. So with this, I've now got, say, 1,000 subdomains. I want to know what's available. I will typically just take my list and pass it into MassScan and give me ports 443 and 80. And then I'll immediately know what application is available, and then I can focus my time on that. As opposed to getting a laundry list of subdomains from, say, like archive.org. They might not necessarily be up anymore. It's going to be a waste of my time to manually go through them. This is a quick and dirty way just to figure out what's available. Alternatively, the OG on this scene is Nmap. And so Nmap is a tool that will do pretty much the same thing. It'll go out, you can give it a list of ports or just scan every port and find out what's available. The cool thing about Nmap is it has this scripting engine. And so there's a whole bunch of scripts that you can apply when you're using Nmap. So in this example, I'm using HTTP enum to see what files are available. So I spun up just a quick linode. On that linode, I put on test.php, brand new linode. No reference to test.php anywhere. It just happens to fall within the word list that HTTP enum is looking for, so it finds it as well as the server status, potentially interesting folder. Other cool scripts that it comes with are like HTTP title, so it'll just scrape all the titles. So that's good when you're looking for common things like PHP info or debug pages or something like that. DNS brute will also do subdomain enumeration. So you can go ahead and just use one tool for subdomain enumeration as well as port scanning. They also have a sitemap generator, so you can use a script to spider your site and have at it. And the reference here to the HackerOne report is Zephyrfish. Hacker was looking at Pornhub, and when he was testing Pornhub, not looking at Pornhub. When he was testing Pornhub, he nmapped them and he found that they had memcached unauthed, right? So then he had remote code execution against their server because that was available, and he could do that from port 11.2.1.1. So as I mentioned, screenshotting for visual recon. So we've got this laundry list. We kind of know what's up because we used MassScan. We checked for 80 and 443. We can then give this list to a screenshotting service, which will go ahead and grab all the headers for us, as well as a visual depiction of the site that's available. So headless Chrome is becoming more and more popular to do this. So this tool from OJ Reeves is Go Witness, and so it's written in Go, happens to be very fast. And sorry, I just forgot my timer. What this will go ahead and do is it'll go grab a screenshot of every subdomain that we've given it, and then we can generate a report for that. And so once I have that report, I just spin up my server, make it available, and I can visually scroll through, and you'll see in the GIF in a second, what I'm actually looking at. So you see reports generated, and then all of a sudden I've got all the URLs. I can see if it's a 443, 404, if there's auth in front of it, no auth. The headers are interesting because they will play into like different security vulnerabilities down the line. So unfortunately, one of the things I don't talk about, but does come up in Visual Recon, is like a CORS header. So if you have a CORS header, that's if that's set, one of the things that a hacker will immediately test for is to see if that CORS header is properly configured, right? Because that will allow for cross-origin communication. And so if you haven't properly set it up, maybe your anchor is incorrect, maybe you're allowing null origins, then an attacker can start reading information from a malicious site against your vulnerable site. The alternative tool to this, that's very popular and is actively being developed, it was just rewritten in Go as well, is Aquatone. So it's by Michael Hendrickson. He's done Aquatone as well as another tool we'll look at, GetRob. And so Aquatone was rewritten such that it'll go one step further than Go Witness. It will start clustering your results. So if you have a whole bunch of 404 pages, it'll just put those together in a group and say these are all 404, same for 403, 401, and what have you. And it's also got customizable output. So if you want to take the output from the tool and then pop it into another tool, he's made that available. So Aquatone is the other tool that you want to check out. Where am I here? So once we've done that, we've looked and seen, we have our laundry list, we looked at the ports that are available, we've screenshotted. Now we just want to start seeing what content is available. So we talked about this briefly with Nmap, but there's other tools that can do this as well. And so the key here is really just finding files that you left off that might be a backup. So tools will permeate based on what's available. So if they find, test.php, they'll look for test.php.back and see if you're disclosing anything. SQL files are a great example of that. If you've left SQL files on your server and they happen to be backups, tools will make that easy to find. And so for me, I found this be wildly popular when I'm looking for like hidden directories, especially, as well as like functionality that's on the site but just isn't published. So recently, as last week, there was functionality that just wasn't finished by what looked like a third-party developer. They didn't list it anywhere on the site. They didn't think anybody would find it, I assume. And through brute forcing, ended up finding that, and it was just riddled with problems. So like everything else, there's a tool for this. So pretty much if you're hacking on anything, the tool of choice is going to be Burp Suite. It's a web proxy that will sit between your browser and the server, right? So you can monitor your own traffic, manipulate it, play with it. So if you're interested in hacking, I definitely recommend Burp Suite. The alternative is Zap proxy. And then there's Fiddler and a couple others. But Burp is my go-to. But if you buy Burp, it's an annual subscription. I think it's like $350 US. But it comes with some great tooling. So the first is Discover Content. So here's the screenshot for Discover Content. And you'll see kind of we define where we're going to start. And then we can tell it how many directories we want to actually go down. So if we find one directory, we can start brute forcing within that, and so on. So the default is 16 for the depth. I usually turn it on to like 2 or 3. But then we have full control over what file lists we're going to use. So that's a new addition. We can just add a custom list. SecLists is a good GitHub repository for that. It's maintained by Jason Haddix as well as Daniel Meisler, I think. And they just grab a whole bunch of security lists that they can find and just pop it into one GitHub repo. So there's really good word lists in there. The RAF word lists are what I end up using. As well, as I mentioned, the file permutation is down at the bottom. You'll see it's got reference to the file extensions. You can test kind of like what it finds and continue to work off of those with common extensions that it finds on the site. Intruder, the other reference to that from Burp Suite. So Intruder is a tool that will just kind of like hammer home a test for you. So if I'm looking at, say, I have a record ID and I want to test all the record IDs from like 0 to 1,000, I can give it to Intruder and then just give it like this iterator. But it also allows you to go ahead and take, say, the first, take a request like to Shopify.com, set a payload at the end of Shopify.com. So I say I want to add something to that domain, and then I'll just give it a word list of all common files or common words or common directories, and then just let it have at it, and it'll go through, you know, a word file of 30,000, 100,000, whatever, start it, and just start testing out those requests, and then you can sort by, say, like the status code that's responded. So if you get like 200 on directories, you know that those are available versus 404, depending upon the pattern on the site. But you can also do it for files as well, and so that's just kind of like the quick and dirty way. So I typically end up using both of those. But there's also GoBuster. So written by O.J. Reeves, again. GoBuster is very similar. It's just the command line tool to do this. So you give it a word list, you let it have at it. It's got a ton of different flags, and it's highly customizable. So here, you know, passing in the verbose flag, you can see what directory it hit on, what directory it missed. But it also has the ability to do DNS brute forcing as well. So you can pass in different flags, give it subdomains, give it a domain, and it'll go at that as well. So because it's written in Go, again, very fast, and there's a lot that you can do with it because it's highly customizable. Moving on to secrets. So once we've kind of enumerated what we have to kind of play with, we're going to start poking around the perimeter and starting to look to see if you've leaked anything. So Michael Hendrickson wrote Aquatone, also wrote GetRob. So GetRob is a tool that will go and you give it a seed organization. So in this case, I give it Shopify. And it'll go and it'll start parsing all the repos that Shopify has that are publicly available. But as it does that, it'll look to see who's committed to Shopify's organization or any of those repos, and it'll add them into my list as well. So you can see here I've got 186 targets. That's because 185 people have committed publicly to Shopify repos, and so it grabs them, and then it's found 106 repositories that it's working through. And it's only at 106 because I stopped it. This would go on for quite a while, and so you'll see the duration is 8 minutes. As it starts finding files, it will just start populating the results for you. And so this handy UI is a server it comes with. You just kind of give it a flag to spin up and bind to an address. Once you do that, you can visit this online. It's available, and start working through all the files that you found. So it's got a word list. So you'll see it's looking for like .pem extensions. It'll look for like credentials, secrets, password, just a whole bunch of specific words or references, and then makes them available to you. And so that reference to the HackerOne report, that's from Mikhail, one of the co-founders of HackerOne. So he found a Rails secret, and so with Rails 4 or whichever version it was, once you had the Rails secret, you could then essentially have remote code execution because you could sign your own secrets, and I think they were being unmarshaled, and then as a result, he could execute his own code. And so if you want to find an interesting one about why Rails secrets are fun, that's a good report to read. Alternatively, this is an example from Shopify. We had a hacker who was looking at Pastebin, so he came across reference to document there from Shopify, and he found that we had a Slack token that was in there. So that Slack token's been revoked. The Pastebin is still up there, so I'm sure you could find it if you really want to dig for it. But essentially, that Slack token just allowed you to post into our channels. You couldn't read anything out, but again, still a vulnerability. We paid for it. The interesting thing, talking to the developer in terms of like why we had posted the Pastebin, it was because Slack didn't. We exceeded the maximum content that the person was trying to share with another developer. And so this was just so long that they didn't realize that down at the bottom of it was reference to like the object that had their information, which included a Slack token, right? So just a crap ton of information buried within it, which is another example we'll talk about later when we're looking at attacking applications. So lastly, looking at open collaboration tools. This came, or rather I learned of this from a tweet. Unfortunately, I can't find the tweet. I can't remember who it was, so can't give them credit. But essentially, looking at open collaboration tools. So things like Trello, Google Docs, social bookmarks. Using a simple Google Dork, like site Trello.com, and then in the target, put in whoever you're going after, and you'll find a whole bunch of Trello boards that some of them are just people referencing the company, but sometimes you'll be lucky enough to find an employee who's actually posted something or is using it for internal use. Example from Shopify is we had like social bookmarking. So we had a hacker who was just looking for this particular social bookmarking site, popped in Shopify.com, and they found one of our support people who had like their own social bookmarking site, and they had reference to internal Shopify sites, and I think like 1 or 2 of them didn't have proper auth on them. So as a result, he found a whole bunch of information disclosure, reported it to us responsibly, and we paid him for that. So those are always good. I gave the 3 examples there, but there's way more. Like Pivotal comes to mind. They have an online collaboration tool for project management that you can use and abuse. So just to recap lessons, I mean, it's kind of obvious, but don't assume when you launch a subdomain that it'll be hidden, regardless if you haven't published it anywhere. If you give it HTTPS and it has a site-specific cert, that cert's going to show up in transparency logs. That's the most general. If you use the wildcard cert, people are going to brute force it. There are people that do this professionally and repetitively. Don't leave ports open. If you're using a service, always check to see what that service is making available. And you can run Nmap yourself. Just check out your own org. Close things down if you don't need them. Remove unneeded files from the system, right? Like don't put them on the server thinking that they're going to stay hidden because you will forget about them. They will be found. And if it's something like a SQL backup or something with passwords, it's just going to do a lot of damage. So always assume that those files are going to be found if you put them on the internet. Similarly, don't ever share plain text passwords. If you do, rotate those passwords or those secrets. You have to assume that once they're out there, they're going to be found one day, and then if they're found, they're going to be used and abused and potentially pivoted off of. So just don't do it. And if you're using collaboration tools, always make sure that those collaboration tools are locked down. So let's look at how we can actually attack the application, and we'll look at specific examples here. So the first one I wanted to talk about is one that I have found more and more commonly is WebSockets. So the reason why WebSockets are fun is because the same origin policy and cross-origin resource sharing only apply to the HTTP URI scheme. So that begs the question, so what? Well, WebSockets are client-server communication that occurs over the WebSocket protocol, not HTTP. So if that's the case, when we have a burp request, we'll go to the server, and we will go to initiate that connection. The server will respond with a 101. And so that 101 then switches the protocol over to WebSockets. So me as a hacker, as soon as I see 101, I kind of get excited because people don't realize the proper way to authenticate these. Once the connection is actually established, any origin can now read and write to that WebSocket. Right? So if you allow an arbitrary origin to connect to your WebSocket, unless you're doing the authentication as like a first step in that connection, essentially that application is going to be, or that origin is going to be able to read and write to that WebSocket. Right? So I'm going to be able to exfiltrate data from your application because you did not properly authenticate the fact that I can create this connection and read from it. The browser isn't going to save you. That's the difference between HTTP. HTTP as malicious.com, I can't make a request to victim.com and read that request because the origin is different. The browser will always save you in that case because it's got swim lanes, right? It will not allow attacker.com to go into the swim lane of victim.com unless you purposely screw that up. Whereas WebSockets will. So here's exploit code. So this is the code that I typically use. I borrowed it. I'll give the source after. But first and foremost, we just create a new socket, and we give it the target site. And so if you're not authenticating, that connection gets made. And then I can go ahead, and I can read that request coming, or that response coming back that's saying the connection is done. And so now we can start communicating. And so we start communicating by this next piece, where I just go ahead and I start sending a message, right? And it's simple JS code. I send the message out, I read the response, and we go back and forth, and I can exfiltrate a whole bunch of data. It's different from, say, the impact of a cross-site request forgery, because that is just one simple request that goes out, whereas here it's full back and forth, and the limitation really just depends on what you've done on the back end in terms of the communication for the WebSocket, like what you're providing, what makes it available. The other potentially difficult part is just knowing what you're expecting from that. So I mentioned that, like if it's an administrative side, it might be a little bit more difficult to exploit, because I might not have admin privileges, so I might not know what the WebSocket is expecting, and sometimes the connection just closes randomly and becomes annoying to exploit. So the issue, the fundamental underlying issue, is the fact that you are authenticating a WebSocket using cookies. And that's a problem because browsers will always helpfully send your cookies along, because they don't know when and when not to on making a request to an origin, right? The browser will helpfully just send the cookies because it's not up to them to decide when the cookies get sent. So the onus becomes yours for authenticating whether or not you should be establishing that connection. So as I mentioned, I stole the exploit code. This is actually the source where I learned about cross-site WebSocket hijacking. They have a nice POC online that you can actually go ahead and test sockets with. So the solution, it's a simple cross-site request forgery token or an origin check, right? The origin check arguably is probably the best. Rails 5 out of the box will do the origin check. So if you're using, I think they call it like cable or something like that. If you use a WebSocket that comes built in with Rails 5, it will have an origin check in there to prevent you from having this vulnerability on your site. So what does this look like from our example before? They've added an SID parameter on the URL, right? Like that's unguessable from an attacker's perspective, so you can't get that. I've also seen others where cookies are sent, the connection's established, but then the CSRF token is sent, but that's very few and far between. Essentially, I think maybe 9 times out of 10 that I've seen this vulnerability, as soon as I can create that connection off of cookies, I'm good to go and start exfiltrating data. Password resets. This is another old one, but still one that I see a lot, actually, especially with ASP applications for whatever reason. Like enterprise ASP, it's almost like this was by default for a long time. I haven't looked into it to figure out why, or if they've changed it, but essentially if you're going after an enterprise and you see they're using ASP, this is like the first thing to check. So the host header is attacker controlled, right? If I send a request to your server, the host header, I can always manipulate my own host header. I can't do that remotely for other people, but I can always do my own. So as a result, you cannot trust it. So if you're using the host header to generate password reset links, you're going to have a problem, right? Because I can send any host header that I want. You'll use that host header to generate a password reset link and send that to a victim. And I would assume 9 out of 10 victims, maybe 99 out of 100 victims, won't look closely at that URL that they get. That's just a long value to reset their password. And so other sites will also use the host header for authentication. So this was written about by like James Kettle on his blog, and it was 2013. So it's been around for a while. In his practical host header attacks, he's talking about password reset links. But there are recent Google write-ups where they had misused the host header for authentication, and which led to big bounties. Recently, a friend just came across one where he could put in anything that just wasn't the actual host header, and he got access to an admin backend. For whatever reason. I'm not even sure how you would screw that up if you wanted to code it. As I mentioned, ASP applications are terrible for this. So what does it look like? I apologize for the blackout, but this was a government site that I was testing with permission. And so I sent the password reset request, added .test.com to it, and then the email that I received was exactly that. Password reset, do not reply, coming from the application, and the link is to .test.com, right? So if I'm a malicious attacker, I'll just register like a 5, if I'm lucky enough, maybe a 4-character domain. So it just pops in a couple extra characters. Look at the laundry list in there. If you're lucky, like this is going to come out of the blue for a victim, so they're just going to suddenly see, hey, you got to reset your password. There's no messaging in here that says, if you didn't initiate this, don't worry about it. Don't click on it, which is great because they're not warning the victim about it. It's just kind of like, hey, you need to reset your password, and then click on it. Because it's a URL parameter, it's automatically linked into the server logs. As an attacker, I just take that. I've got your token. I can reset your password. I now have your account. So the solution, just like input, never trust anything the attacker can control. The host header is attacker controlled. Don't use it for any type of, say, password resets or authentication. This one was, I think this is probably my most favorite. I'll give you the backstory after we kind of walk through it. But the file system API, right? It's a new API, I think with HTML5. And essentially, you have this local file system interface that works through the file API, and it gives you this sandboxed file system for the browser, right? And you can add a flag that's either persistent or temporary. So persistent means that files never get deleted, right? And it's an explicit permission that the user has to grant. So you ask for permission, you set a certain size, user okays it. If you ask for temporary, the user does not have to permit it, but the caveat is the browser can wipe out the files at any time. But there's no guarantee when that wipeout will happen. It's all kind of browser dependent, black magic in the back end, which is good for us as well. But this was specifically a vulnerability that I found. So, sorry, I screwed that up. So the key here was that, according to the documentation, the sandboxing is to a specific single origin, right? So this comes up in like the security considerations. It's like, don't worry. When you require this file API access, it's only going to be limited to one origin, so that origin can only ever grab its own files. That's awesome, because if a user has a shared computer, all of those files are going to be in one origin, right? It doesn't have this concept of multi-user access, so everything is going to be there and be accessible. But even better, what happens if you have a cross-site scripting on that one origin? Well, you can now exfiltrate files, of course. And so this is what made it awesome for me. I was working on a sensitive target, and when I was reviewing their JS files, I saw right at the beginning, it was using big capital letters, persistent storage. I didn't know what it was talking about. I didn't understand. But working through the functionality of the site, I saw that I could upload a file. And so that's always a red flag for an attacker, right? If you can upload files, you can get something on there. You want to see how that server is going to use that file. Like, think of image magic and the image tragic vulnerability associated with that. So when I submitted a file, I was looking at my Burp proxy history to see where that file went, and there was no request for that. And I thought that was odd, scratching my head, so I tried it again. No request. But it was a dialog box that I was uploading to, and it said upload, and I showed it in the browser, and I didn't understand what was going on. But then there was like this execute button, and when I clicked execute, then the HTTP request went off. So when I was reading the JS files, I realized that they're using the file system API. So nobody else had really paid attention to that, and it was a 2-week test. So I talked to the people, and I said, if I get cross-site scripting and I can exfiltrate files, will you pay for that, even though kind of the cross-site scripting is already known about? And they were like, yes, definitely do it. But it took me a while. I left it for 2 weeks just because I got lazy and I found kind of like a terrible design pattern that I was able to exploit throughout the application. And on the last day, I went back, and still nobody had found this. Nobody had used this. So I went ahead, I did it. I did up the POC. I submitted it just as the target was ending, and they paid me $4,000 for it because I could exfiltrate sensitive files from a server. So let's look at the code. So first things first, we're going to go ahead and we're going to initiate this request system, right? So you'll see that I'm requesting persistent access, and then I think it's the amount of space that I want, and then the initial function that's going to kick off once that connection, once that's done. And so because the user is already allowed for persistent access, I think 99% sure if my memory stands correctly, they're not asked again for allowing persistent access. So this just kind of happens silently in the background, which is great for us. So once that's done, I'm going to go ahead and I'm now going to read all the files that are available in this file system API. And for each one of those files, I'm going to pass it off and read all the contents, and then just post all the contents to my server. So now I've gone ahead and I have exfiltrated all of these files. Even better, if you have persistent access, I would argue that 99 out of 100 users are never going to clear those files off of that persistent access. Like they're always just going to sit there because people are intrinsically lazy. So, I mean, the solution, I would argue that there isn't a good one. It's really a choice that you have to make. Like, do you really need to use this file storage? Even with temporary file storage, the documentation that I can find doesn't say when those files are going to be deleted. It just says that they will eventually be deleted. So again, cross-site scripting, if I can execute that, chances are I'm going to have some juicy files to exfiltrate, depending upon why you're using this functionality. API objects. This one, again, very dear to my heart because this is like the highest payout that I ever received for vulnerability. And it was, I don't know, just not, there's no reason for it. So consuming APIs with a front-end JavaScript library seems to be very popular now. And I've seen it with like React. So you have like a front-end React templating system, and then you have this API to interact with in the back end. And so you start making requests, and then you have to populate that. And so what I've seen sites do, and I have 2 examples of it, is they end up rendering the API within the page source of the actual page. So when you visit a page, you just see like this huge laundry list of information. If you kind of like scroll down to the bottom, you see all of this like JSON that is rendered in the page and then just actually extracted out. And so the question is, what happens when you JSON an API object in the page source to render content? Well, the answer is you get this. So this is a report that I sent into a site. If you're from out of town, maybe it's a site that you're using. And essentially, it just leaked a whole bunch of private information. So I got the birth date of a user, I got their email, I got their IP, I got their most recent IP, I got their password hash, I got the password salt, as well as like an iPhone ID, Facebook ID, recent payment status, and a whole bunch of other ones that I wasn't too sure about. So when I reported this, I think I reported it on like a Friday, and same thing, about like the Monday it was like done, right? Like they had developers on the weekend come in and fix this. Sadly, Shopify did this. We have exchange.shopify.com, which is now like exchangemarketplace.com. But we were interacting with Shopify core, right? So you have your own store, and that store has all of your information. And so Exchange wanted to get some of that information to help render its listing. So if you're going to sell your store on Exchange, it needed to know some information about you. And they had mistakenly gone ahead and JSON the object, and you'll see it's down there at the bottom, Shopify shop record. So Shopify shop record has just a whole bunch of information about your shop. They had JSON'd, didn't realize it, and so as a result, they just had all of this information that was spit out. And somebody responsibly disclosed it to us, and we paid for it, and we had it gone within a few hours, right? Because it was a simple fix. But it was all from the design pattern of using React, interacting with an API, and then just mistakenly spitting out that entire object. So again, the solution, don't ever render a full object in attacker accessible content. And I can say that because when I started out as a developer and had no clue what I was doing from a security perspective, I got tired of mobile developers saying, hey, I need this added to the object, I need this added to the object. So I just said, screw it, here's the full object. And that was a huge problem. I don't know if that code is still in production or not, but I don't work at that company anymore. So that kind of rounds out the presentation. I had a whole bunch of other stuff we can go into in terms of advice, but I stopped tracking time, and so I have no clue if I'm on time or off time. So we can talk about questions if there's any up front.